Hi everyone, welcome back to Cody's Lab. So in this video I'm going to be igniting several different materials inside of a vacuum chamber. But first I'm going to be starting with some brown paper at normal Earth atmosphere. As you can see, I'm lighting it with my laser and I'm easily able to ignite it. Okay, let's close the door, pump out the air, see what difference it makes. Now that most of the air is gone, let's shoot it with the laser again and see if it still ignites. As you can see, there is no ignition. Which makes sense, because I've removed almost all of the oxygen. I still see smoke though. In fact, so let's get a closer look at that. Here you go, safety first. Just put on some laser safety goggles onto the camera so you can see it a little bit better. Okay, let's see what happened to the paper. So the paper was definitely charred by the laser. You can see it's blackened and in many cases completely burned away. But I wouldn't say this is burned, rather the laser heated up the materials that make up the paper, mostly cellulose, to the point where they pyrolyzed and broke down into their constituent elements, mostly water vapor, CO2, and carbon. And maybe some other oils and stuff, which was propelled out with the smoke and is now stuck to all the surfaces inside the chamber here. So the atmospheric pressure inside the chamber is roughly the same as what it would be on Mars. If I zoom in on the pressure gauge, you can see I'm right about 7 millimeters of mercury. Let's zoom back out here. Now I'm going to unplug the vacuum pump. That way I don't have too much disturban in the airflow inside the chamber. Now we're going to see if the smoke rises when I shoot my laser at this black plastic here. Made a nice little smoke ring there that shot out and then fell. Let's try hitting the top of the plastic. I don't know if you could tell, but the smoke did rise up and then it expanded out and it is now settling to the bottom of the chamber. Let's try it again on the bottom of it. See, the smoke does rise, but then it falls shortly after. Let's try it zoomed in here. Let's focus on the bottom here. You see the smoke rises up and then falls. Fascinating. Let's see what it does when the chamber's pressurized. See, the smoke just rises really far. A nice thin stream. Zoom back out a little bit. You see the smoke goes almost all the way to the top of the chamber before it just kind of gets caught and then slowly disperses out throughout. The paper failed to burn because it didn't have any oxygen, so how about something that has its own oxidizer, such as gunpowder? You see, this is a mixture of charcoal, sulfur, and potassium nitrate. When heated, the potassium nitrate gives off oxygen, which the sulfur and charcoal uses to burn. So I've got a little bit sitting in there. Let's apply the laser goggles. And let's light it off. First in the atmosphere, and then in the vacuum. Okay, as you can see, it produced lots of smoke and burned rather quickly. Most of the air is now gone. Let's see what happens. The gunpowder did not ignite. I saw some smoke coming off of it, so I know it burned a little. Let's try again more in the center of the pile. And that's it. The gunpowder does not burn. I mean, it burns when the laser's on it, but other than that, no. It doesn't change from one particle to the next. That's interesting. So what I think is happening here is that the hot gas is produced from the burning gunpowder. Normally, as it expands, it encounters other gunpowder particles, heating them up and causing the chain reaction to occur. But in the vacuum, the gases expand so rapidly that they're not able to heat up the nearby gunpowder particles, and so the flame or the fire does not happen. Also, some of you know that when burning gunpowder in open air, it just sort of burns with a bright flame and lots of smoke. But when you put the gunpowder inside of a confined area, say a barrel of a gun, it explodes. It's because the confining pressure accelerates the combustion. Yeah, this is definitely, it didn't burn very much at all. Kind of hard to tell whether or not the individual grains burned up completely or not. So let's try something a bit more solid. Scott Manley actually messaged me and asked if I could try rocket fuel in this test, and so I'm going to be burning some rocket candy. This is a mixture of sugar, potassium nitrate, and iron oxide. This is used in amateur rockets because the ingredients are readily available and the amount of thrust it produces is quite high. So let's light this on fire and see how it does. So this is in Earth atmosphere. As you can see, it burns rather rapidly, producing a little bit of thrust even. As you can see towards the end, it moved it around. So now let's try it inside of a vacuum. No ignition. That's interesting. I did see some little poofs as it tried to burn, but it was unable to sustain itself. So even when it's in one solid piece, it can't chain and continue burning. So I've let a little bit more air back into the chamber. Let's see if it'll burn now. That's a no-go on burn. Wait. It's kind of smoldering. And it's out. Acetone peroxide in the atmosphere in 3, 2, 1. Yes, that's a little bit more volatile than gunpowder is. Acetone peroxide in vacuum in 3, 2, 1. It still didn't burn. I'm actually disappointed. It needs something to confine it in order to get it to burn and then eventually explode. And at atmospheric pressure, the atmosphere does it, but in the vacuum, there's nothing there. So far, nothing I've tried has been successful, but I was thinking about it, and everything I've tried up to this point has produced gases as a product of its combustion. So I thought, what if I tried something that didn't produce gases? How about some thermite? This is a mixture of iron oxide and aluminum. Well, normally this is actually magnesium powder because I didn't have any aluminum on hand. But the idea here is that the reaction will not produce gases. Might make a little bit, but primarily the product of the reaction is going to be molten iron. And molten iron, of course, it's not a gas, so it's not going to leave as quickly, so maybe it can help chain the reaction along. So let's test this out. This is a thermite reaction in Earth's atmosphere. Here we go. That burned up. I can see that there's little bits of iron, some magnesium oxide floating around. A little bit of smoke, but again, that's probably just from contaminants that burned up. So there we go. Let's try it in the vacuum. I did not get an ignition. I see pieces flying all over the place, but none are actually igniting. I'm going to try again with the thermite, but this time I'm going to bake out any volatiles from the iron oxide first. That way, perhaps the laser won't push the pile around quite so much. Okay, I'd say that's fairly well cooked. Let's try it out in a thermite mixture. This time it's been baked. It's inside of a vacuum. Let's see if we can get it to light. There's sparks. Oh, it's burning. It is actually burning. Oh, that is cool. It actually burned. It burned very slowly, but it actually worked. Oh, that was cool. So I was able to get a fire in there. It just, it didn't really look like a fire at first glance, but it was burning.
I know you're out there. I can feel you now. I know that you're afraid. You're afraid of us. You're afraid of change. I don't know the future. I didn't come here to tell you how this is going to end. I came here to tell you how it's going to begin.